Okay, so the idea is to try to show how to solve first order linear differential equation in its general form after we bring it to a standard form of the equation. So the standard form we are talking about is, wait, before we start, what function we are talking about? We are talking about function that we call y, and the function is with respect to x. This is the variable. So it's y with respect to x. This is the function we are looking for in the first order differential equation, linear differential equation. Now, the equation can look, I don't know, anyhow, but it must be first order, namely not more than the first derivative of the y. And we need to bring this function to the form such that it will look like starts with y tag, namely the derivative of y with respect to x. This is the first term, plus px, which is a function of x, and the px times y. This is the second term. All of this, y tag plus px y, equals qx, which again, some function of x. Px and qx are some function of x, but this is the standard form we want to bring our equation to. Y tag plus px times y equals qx. This is the standard form we are going to work with for solving first order linear differential equation. And we are looking again for what is the function y with respect to x. So we will use integration factor method. What the integration factor is, it is e to the power of the integral of px dx. E to the power of the integral of px dx. This is our integration factor. Now what are we going to do in this integration factor? We are going to multiply each term of the equation. Each side of the equation will be multiplied by this integration factor. We can call him IF, abbreviation of short for integration factor. So what will we get? We get a left-sided equation which is multiplied by the integration factor, and right-sided equation which is again multiplied by the integration factor. Now when we will do this multiplication, we will be able to see that the left side of the equation we will get, it is just a derivative of the product of y times the integration factor. Y times the integration factor, take the derivative of this, you will get the left side of our equation after multiplying by the integration factor. So the left side of our equation now, after multiplying by integration factor, is just the derivative of y times the integration factor, taking the derivative with respect to x. The right side of our equation is qx times the integration factor, e to the power of integral px dx. Now, we can take the integral with respect to x of both sides of the equation. Now, the left side is just a derivative with respect to x, so integral with respect to x will bring us the left side to y times the integration factor. That's it. So in the left side of the equation, we are left with y times the integration factor. Now the right side of the equation, which is e to the power of the integral of px times qx, we'll need to take the integral of this. Now we can isolate y. Y is qx times e to the power of integral of px. this is in the numerator, divided by the integration factor, e to the power of integral of px with respect to x, which came from the left side because it multiplied the y. So I just transferred it to be a denominator in the right side. So now we have left with y equals qx times e to the power of px in the numerator, and in the denominator we have left with integration factor e to the power of px. Now all the integrals are non-specific. Namely, we are going to do it integral of px plus c, which is a constant, unknown constant. Also, when we're taking the integral of qx times integration factor, we also should add a constant, let's call it c, or c2 if you want. Now, the c in the integration factor and c in the after we're taking the integral in the numerator, I will be able to add them because e to the power of c is just a constant. Add it with another constant, c1, I can just call it, I don't know, c2 or something. So we will be left with a constant c2 in the denominator. So the final result will be y equals the integral of qx times e to the power of integral of px, all of this plus the constant c divided by the integration factor, again, e to the power of integral of px, and here we also will have a constant, so remember this. Now using other known factors, known results, starts value, for example, will help us evaluate this result and get the constants that we want. Now we will be able to get only one constant, remember this, because the constant in the numerator and denominator, they are in multiplication with the values, so you can just divide them. So you have only one unknown constant. So using the start values, initial conditions of the problem, we'll be able to solve this equation and get you to the needed constant value c. Okay, so this is the idea of first order linear differential equation and how we can solve it using the integration factor. That's it. You have a first order linear differential equation, move it to the general form, create the integration factor, multiply, note that the left side is just a product derivative, use integration, isolate y, note that there is constant, use the initial conditions, solve for the constant, unknown constant, get the result for y. This is the function you are looking for of y. This is the result. This is the solution for the first order linear differential equation using the integration factor. And that's it. Thank you very much. If there are any mistakes or correction, please tell me. And that's it.